We're going to finish looking at the periodic table by talking about what are representative groups. And with representative groups, one of the things we need to look at are valence electrons. Now, we know that every atom has electrons, and we can look at the atomic number and figure out the number of protons and then also the number of electrons. The valence electrons, though, are a very specific set of electrons. These are the ones in the highest occupied energy level. So let's say that we have 6 protons. That means we have 6 electrons. You put 2 in the first energy level, which means that 4 are going to be going into the second energy level. So the number of valence electrons here is equal to 4. And that's going to be very important in bonding. And when we talk about chemical reactions and what elements will bond together or not bond together, it will be because of the number of valence electrons that element has. So that's definitely a key vocabulary word. Very important to know that one. Know what valence electrons are. Now, elements that are in the same group, and remember, groups are the same ones going up and down within a column. They're going to have similar properties because, again, we call them a family for a reason. They have similar properties. But one of the things that they have in common is that they do have the same number of valence electrons. So that's one of the family characteristics or traits. Now, if we look at group 1, remember there's 18 total groups, so we're not going to go through every single 18. We're kind of hitting the main families. These are called your alkali metals, and they have 1 valence electron, so only 1 valence electron. They're very, very reactive. Now, hydrogen is also in that family. If you get your periodic table out, it is not a metal. Hydrogen is a nonmetal, but it does have 1 valence electron, so that's why it's placed over there at the top of group 1. The reactivity increases from top to bottom. So at the top of the chart at lithium, very reactive, and then it increases as you go down. So even though lithium's reactive, it isn't as reactive as some of the ones underneath it. And these also have very strange storage techniques because of how reactive they are. Some of them even have to be stored in oil or under oil because they'll react with like the water vapor that's in the air. So very interesting, some of those. All right, group number 2, these are also metals. These are called alkaline earth, and they are in group 2. They have 2 valence electrons. And as far as reactivity, there's a lot of differences here among the alkaline earth in the way they react to water. So some of them are very reactive and some of them hardly react at all when placed with water. So very unique. Magnesium is one of the elements within that family. And magnesium is used by plants to make food. Just some quick facts here. And also it's mixed with some metals to help make bicycle frames. Calcium is another one in that family. We probably have all heard of calcium. It's needed for strong bones and teeth, but it's also found in coral, pearls, and chalk. Moving on, we're actually skipping quite a bit here, and moving on to group 13. So if you've noticed, we've skipped 3 through 12, which would be those transition metals. So we've skipped all of those. We're over what we call the boron family, because B is at the top of the category. They have 3 valence electrons, and one of the elements that is in this family is aluminum, and aluminum is the most abundant metal in the Earth's crust. So key word there, it is not the most abundant element, but it is the most abundant of all the metals in the Earth's crust. Aluminum is used for a variety of things because it's so abundant and we can get it so readily and so quickly and easily, and that way it also makes it cheaper because there's a larger supply of it. So a wide range of things from packaging, we know aluminum, foil, car parts, airplane parts, gutters on houses, and so on. Lots of uses. All right, moving on to the carbon family, which is group 14. This one, if you haven't guessed the trend here, we're increasing our valence electrons by 1 every time. So this has 4 valence electrons. Group 14 has 4. And these, the metallic nature increases from top to bottom. So carbon is a non-metal, but if you go down the carbon family, you hit some metalloids and then metals at the very bottom. So they're more metallic at the bottom of the family. They also, except for water, which is the most abundant compound in your body, carbon is the most abundant element that you have in your body. Proteins, carbohydrates, fats, lipids, they're all carbon based. Silicon is another element within this family. It's right underneath carbon, and it's the second most abundant, and it's found in just a wide variety of things: rocks and sand, glass, clay, all those things have silicon in it. The next family is the nitrogen family, so group 15. Sticking with our trend here, we're increasing our valence electrons by 1, so we have just 5. And fertilizer is commonly made from nitrogen and phosphorus, which are both elements within the nitrogen family. Moving on to group 16, we have the oxygen family, and the oxygen family has 6 valence electrons. Oxygen is the most abundant element in the Earth's crust. So aluminum is the most abundant metal. Oxygen is not a metal. Oxygen is the most abundant element. Obviously, we need it to stay alive. The ozone is made up of oxygen, and it absorbs the radiation from the sun. Areas that have less ozone, people in those areas normally see higher chances of skin cancers because the ozone isn't blocking those radiation particles from the sun. You also have sulfur in that family, and sulfur is also used to make fertilizer. So nitrogen and phosphorus are right beside sulfur. They kind of all have some similar traits there. To left, halogens are group 17, and they have 7 valence electrons. They also are very highly reactive nonmetals. So group 1 were your very reactive metals, and group 17 is your highly reactive nonmetals. We have several different elements in here you may have heard of. Fluorine, for example, we use those to help prevent tooth decay when you get fluoride treatment at the dentist. But fluorine is also used in the nonstick coatings that you get in like your pans for cooking. Chlorine we probably heard of. We use that in pools to help treat water to kill bacteria. And then iodine, and iodine is a necessary element for your thyroid gland to work properly, but you may have also seen iodine like being rubbed on like skin before surgery. Iodine can be used to kill bacteria and things as well. So it keeps around where maybe you're getting an incision during a surgery. It keeps it from getting infected. And then our very last group is the noble gases. The noble gases are group 18. And if we're sticking with our trend, we're going to be hitting 8 valence electrons. There is one exception, though, because helium is so, up toward the top where it only has 2 electrons. So it can't have 8 valence electrons when it only has 2 to begin with. So helium is the one exception. Everything else, neon on down, has 8 valence electrons. As far as these elements go, they are very, very unreactive. You will not see these bonding with other elements on the periodic table, and that's because they have a full energy level. Their 8 valence electrons is good, so they don't want to gain or lose any electrons, but they're also colorless and odorless, which is just an interesting little characteristic there.